In this tutorial today, I'm going to be teaching you about S-curves / progress curves, why you need them, and how to make them, and how to read them. So first of all, what is an S-curve? An S-curve typically looks something like this on an ideal project. You're going to have different parts of the life cycle for, say, a piece of equipment like delivery date, planned install date, actual install date, planned turnover date, actual turnover date. And the curves are going to ramp up and kind of have a steady progress, the derivative being pretty much an even slope across here, and then you're going to go on to the next part of the curve. So this is an accumulative line of what you're getting done every day as far as deliveries, and then it goes into like actual installs would ideally be a little bit faster than your planned installs, and actual turnovers would be a little ahead of schedule, hopefully, or maybe more. So how do we make these, and what do they look like in real life? How do we use them? So let me show you some example data. If we go to this Excel example data, we'll see these same columns. We have equipment ID, and then we have delivery date, planned install date, actual, all the way to actual turnover. So these dates are in columns, and normally we're used to seeing dates in a schedule as each column in a Gantt chart being the dates across the top. Now, Gantt charts aren't great in this situation because a Gantt chart is going to leave you with tons of white space. It's annoying to track. It's annoying to enter the data. You get tons of line items. You have, for every column here and every date here, you have to have another line item here to keep track of it. Now, I'm mixing up the planned install and the planned actual, which you probably would combine in a Gantt chart, but regardless, you end up with a lot more wasted space when you're trying to track equipment that is interchangeable. So in this case, let's assume they're distribution panels. They all have tag IDs for quality reasons, but you can move them around, swap them, whatever. So what do you want your plan to look like? Well, using the free version of Power BI, you can make S-curves really quickly. So what we did is we imported that Excel data by going to Get Data and then going to Excel, selecting the file, and here it shows up. Now we're going to drop in our dates into the values, and we'll try to do it somewhat in order. So we got like delivery date and planned install and our actual install, along with our planned turnover and our actual turnover. So we got all these dates in here. It's kind of hard to look at. You can't tell where the problems are. And so what we'll do is we'll import a custom Power BI visual where you go to import a visual, and you can download that from login.quantcon.com and go to the download section. You can download curves. So wherever you download it to, you can import it here, and then we'll switch to the curves visual. So now we can see our S-curves brought into Power BI, and what's cool about curves is it automatically adds up these accumulation lines. So we don't have to worry about making formulas to figure out how many are added up every day. Curves automatically does that for us. So we are going to now examine this S-curves from this data to see what are the problems in this data. One thing you can do in curves is it'll also display bar charts for you. So let's start there. Let's look at the bar charts. So we go to General View. Right now the bar opacity is 0. So let's switch to the bar chart view, and then we will go back to the line view. So seeing them together is kind of messy, so most people don't really want to look at them this way. So let's turn off the lines. So now we have a column chart which is based on the left axis, and the column chart's interesting because it's going to show us a couple things. It's going to show us gaps where we don't have an activity going on. So for example, the blue bars represent delivery date, so we can see that for like 2 weeks from April 20th to May the 4th there's no deliveries happening. So the bar chart's good at seeing those gaps in the progress at different steps. It's also good at seeing the peaks. So we can see that the deliveries are coming in really quite in batches. Like we get like 100 of these pieces of equipment, and we wait a couple weeks, and we get 60 more, and then a couple days we get 60 more. So they're coming in waves. So if we go back to the line chart, we can start to see how those waves are going to affect us. So we change back the opacity of the line chart, and we change back the opacity of the bars to 0. So with the line chart, one of the first things we want to look for is how do the lines, or with the S-curves, how do the lines interact with each other? So if you remember that ideal situation where the lines don't cross at all, and they just kind of stay out of each other's way, and you have gaps between them, which means you have substantial inventory before you're installing and things like that. If we go back to here, we see, okay, we got something a little more complicated than the ideal situation. So let's look at how the lines interact with each other. So remember, we talked about the deliveries were batched. So you can see here, it's like a stair step. As the deliveries come in, they step up, step up, step up, until you finally get to all your deliveries. And what we can see down here is a problem where our lines are a bust because the planned install date is crossing the delivery date. So, and as we can see, our actual install date gets installed. Physically, you can't have your actual install date accumulate faster than your delivery date. So you see the actual install date stays to the right of or under the delivery date the whole time, but there's a bust a couple places with our plan versus delivery date. Another thing you can see is by looking at the horizontal differences between, I'm going to switch to PowerPoint because I can draw some boxes without breaking things. So if we switch to PowerPoint, where I can kind of highlight it easier, so we see, I pointed out where the lines overlap. What we can also do is we can look at the differences between lines in the vertical direction, and we can start to do things like measure inventory. So it looks like right in here seems to be the biggest delta between planned install and delivery date. So that basically is our inventory. So we can see at some point we have to store maybe 75 of these pieces of equipment. So you can check your warehouse to see, do you have enough room to do such a thing? The other thing you can see is that the actual install, the yellow here, and the planned install, they're diverging a little bit. They're moving away from each other. And if you measure in the horizontal direction, you can see how much they're missing each other. So you come down here and you say May 17th to May 25th. So basically it looks like we're running about a week behind in getting our actual install relative to our plan. Now down here that might have been due to material, it might be labor productivity, who knows, but you can see that you're falling behind by about a week. Now the happy part of this story is apparently you had some float in your schedule because your turnovers for a while kept up. Your actual turnover dates are staying left of your planned turnover dates until here where your planned install date has plateaued and now you're missing your schedule. So you're seeing all this information in one visual, opposed to trying to look at a Gantt chart where you're going to be scrolling and scrolling for days trying to see these correlations of how's it going, what's the bust, pages and pages of PDFs, or if you're lucky you actually have a P6 or a project license. And another thing we notice here is that the planned turnover date is kind of an exponential curve. So if you did this early enough, you might ask yourself, why do I have an exponential curve anywhere in my plan, whether it's deliveries or anything like that? Because that means you have resources that have to go up somewhat exponentially. And as we can see with the actual turnover plan, if you drew a line across here, it's more or less linear, like the actual install and the planned install, and it can't keep up. Once this thing really starts to take off and expect all these planned turnovers in a very short period of time, as you can see on the bottom axes, the plan doesn't keep up. With all the way these lines are interacting, that's why we find progress curves and S-curves so helpful in helping us see problems in our plan that a Gantt chart can't show us. Thanks, hope you enjoyed. Please comment below if you have any questions or need any help doing these. I'd be happy to help. Thank you.